Here we go with 3.08. So we're going to solve rational equations by hand now, and we also want to make sure we recognize what's called an extraneous solution, and we'll talk a little bit about exactly what that means. We want to go back to the work we did today in looking at the solving of a rational equation. And what we did, if you remember, is we looked at when we finished simplifying and we got x squared minus 3x minus 2 equals 2, we used Wolfram alpha to solve this equation. So we graphed the quadratic, we graphed the constant function 2, and we found that they intersect at -1 and 4. Okay? And so we said, okay, that's great. Maybe those are our solutions. But to check that we were correct, what we did is we went and we then graphed the original function. And here's the graph of the original function, and we'll notice that at 4, the two functions are not intersecting. Right? There's no solution at 4. The only solution occurs when x is -1. And so what happened is that somewhere along the line, we ended up including 4 when we shouldn't have included 4. 4 is not actually a solution. And so which solution are we going to go with, right? Well, we have to go with the original equation because that's what we're trying to solve. And so the only solution is when x is equivalent to -1. So now what I want you to do is I want you to go back and I want you to look at the original equation and decide why 4 is not a solution. If I look at if I look at this original situation, what would happen if I plugged in x equals 4, if I plugged in 4 for x? Well, you'll notice here I get 4 over 2, that's fine. Here I'm going to get 1 over 4 minus 4, which is 0. Now 1 over 0 is undefined, so the left side is undefined, and right away you realize there's an issue. On the right side, you'll also notice that this quadratic factors, and it factors to x minus 4 times x minus 2. And so you'll note on this side as well, when I plug in 4, I'm going to get an undefined function. So what we have to do is we have to mention the excluded values when we're going through and simplifying. So if you take a look at this step here, moving from here to here, we multiplied by the quadratic on both sides so that we got it out of the denominator. But realize again that this is just x minus 4 times x minus 2. X minus 4 times x minus 2. And so when I multiply by that on either side, x minus 4 and x minus 2, when I multiply that, and I'll just pretend I have them there, they will cancel because they're essentially something over itself, which is 1 over 1. And so I end up with no more denominator. But I can't forget that the original function had those denominators, and so I have to include them as values that don't work. So this would only be true when x is not equal to, and I have 4 and there's a couple more, right? I can't have 2 either. Can't have 2 either. So those are what's called excluded values. So when I see that 4 is a solution here, what that's called is it's an extra solution. So we call it an extraneous solution, and we'll look at the definition on the next page. An extraneous solution is a value which satisfies the simplified version of an equation, but does not solve the original equation. And so we get these by forgetting where our function is going to be undefined. So we have to be very clear that we don't forget those values when we're solving. So that's one of the key points that you're going to want to write down. So now go ahead and try solving both of these here. I will talk briefly about each one. We're not going to give you the solution. I'm going to give you a couple hints, and I'm going to expect you to work and put in the time in order to solve them. So go ahead and give each a try on the left side of your paper. I'll give you a couple hints, and you can try it again on the right side. All right, so if I look at A here, if you ran into trouble, it was probably right off the bat. Remember, we're solving these equations, so when I'm all said and done, I want to know what x is equal to, right? I want to solve for the x value that will make these equal. So obviously what I'm thinking about is, I have two functions, and now I could graph them and see where they intersect, but we want to do this by hand. So we want to actually solve for x using some inverse operations. X is in the denominator, and that's not going to work. We want x in the numerator. So if I think just about this right side here, what will put x in the numerator? Well, I could multiply by 4x plus 3, and that would now cancel out, right? Okay, and also over here I would have to multiply by 4x plus 3, right? Okay, so now I've taken care of this side. I no longer have x in the numerator there, in the denominator there, but I still have it here. Well, let's just do the exact same thing. So now I need to multiply by 2x plus 1 on both sides. Okay, so over here, those will cancel out. And now on each side, on the left side, I have 4x plus 3 times 3, and on the right side I have 5 times 2x plus 1. Okay? So you can go ahead and solve from there. That's not too hard. Make sure that you pay attention and see if there are any extraneous solutions. So think back to the original equation and see if there are any solutions which we should not allow. For the second one here, there's a little bit of work we've got to do first. So just like we learned the lesson of always getting x out of the denominator, here we need to realize that if we're adding or subtracting, multiplying or dividing rational expressions, we need to do that. So in order to subtract these rational expressions and get one full rational expression, I'm going to want to go ahead and get common denominators here. So I'm going to have to multiply. This is great. I only have to multiply this rational expression because I can turn this denominator b into b squared by multiplying it by b over b. Okay? And so then I can subtract the two and just be careful, to collect your like terms. And then we can go back and we can say, okay, we have a rational expression where b is in the denominator, we have b in the denominator here, and we can get b out of the denominator by multiplying by those denominators on either side, just like we did up here. Okay, so now go ahead and use those tips. Try it on the other side. I'm sure you'll be able to make some headway. And after that, I've got another problem coming up for you, so put some work in and then we'll move on to the next one. Last one. So Megan solves the equation and finds a solution of x equals 1. What you want to do is, without solving it, decide if that is a solution and explain why or why not, and then solve the equation for x and explain why, if Megan did make an error. Okay, so go ahead, use the same tools we talked about, right? You have two rational expressions, so you'll want to combine them so you have only one, and then you need to get your variable out of the denominator, and you know how to do that. So good luck. I want to just give a quick shout out to Angel and all the fourth period. You guys are pretty awesome.